reaching every learner with compassion, moving everything with passion, driving everyone with dedication. This is Teacher Bayani.
Good day everyone! Welcome to Technoscuela. This is Sir Jonathan, your teacher for grade 11 in electrical installation and maintenance. Today, will surely give us another fun and learning field experience. But before we proceed to our discussions for this episode, I will give you first a brief background of our lesson for today. Our lesson focuses on basic technical drawing in electrical. Your module, at the same time, contains information and suggested learning activities in the said lesson. After a short break, we will start our discussion. Please be ready with your module, paper and pen for our activities.
Designers follow a process in developing their vision for their projects. Electrical engineers start the process of designing electrical systems by estimating the total building electrical power load. Then they plan the spaces required for electrical equipment, such as transformer rooms, conduit chases, and electrical closets. The amount of energy that a building is permitted to consume is governed by building codes. A building energy consumption analysis determines whether the building design will meet the target electrical energy budget. If not, the engineer must modify the electrical loads and reconsider the projected system criteria. The engineer will incorporate energy conservation devices and techniques and draw up energy use guidelines to be applied when the building is occupied. These techniques depend on the day-to-day voluntary actions of the building's occupants, which are hard to determine during the planning phase. Once the electrical load is estimated, the engineer and the utility determine the point at which the electrical service will enter the building and the meter location. They also will decide on the type of service run, service voltage, and the building utility voltage. With the client, the engineer looks at how all areas of the building will be used and the type and rating of the client's equipment, including specific electrical ratings and service connection requirements. The electrical engineer gets the electrical rating of all of the equipment from the HVAC, plumbing, elevator, interior design, and kitchen consultants. This communication often takes place at conferences during which the electrical consultant makes recommendations to the other specialists regarding the comparative costs and characteristics of equipment options. The electrical engineer is responsible for determining the location and estimated size of all required electrical equipment spaces, including switchboard rooms, emergency equipment spaces, and electrical closets. Panel boards are usually located in closets, but may be in corridor walls or other locations. The architect must reserve spaces for electrical equipment. Next, all lighting, electrical devices, and power equipment is circuited to appropriate panels. The engineer will detail the number of circuits needed to carry the electrical load, the types and sizes of electrical cables and materials and electrical equipment, and their placement throughout the building. Panel schedules are prepared that list all of the circuits for each panel, including those for emergency equipment. Panel loads are computed that show how much power is circuited through that panel. The engineer prepares riser diagrams that show how wiring is run vertically and designs the panels, switchboards, and service equipment. After computing the wiring sizes and protective equipment ratings, the engineer checks the work. Then the engineer coordinates the electrical design with the other consultants and the architectural plans and continues to make changes as needed. Interior designers are also responsible for showing electrical system information on their drawings. The electrical engineer uses the interior design drawings to help design the electrical system, In new buildings, the location and size of equipment rooms, including switching rooms and electrical closets, should be coordinated with the electrical engineer. The interior designer should be familiar with the location and size of the electrical panels and with building systems that affect the type of wiring used, such as plenum mechanical systems. Must know the locations of existing or planned outlets, switches, dedicated outlets, and ground fault circuit interrupters. Must coordinate lighting fixtures, appliances, equipment, and emergency electrical systems with the interior design. May need to coordinate the location of equipment rooms. Should be aware of the presence of an uninterrupted power supply or standby power supply. The interior designer does not usually need to be completely familiar with electrical code requirements, but there are several areas that may affect interior design work. Building codes set limits on the total amount of energy used by the building, including equipment and lighting. The NEC is also known as NFPA 70. It is revised every 3 years. The NEC sets the minimum standards for all electrical design for construction. Interior designers rarely use the NEC because it is the responsibility of the electrical engineer to design the electrical system. On smaller projects, a licensed electrical contractor will know the codes. However, since interior designers typically will specify the location of electrical outlets and fixtures, they need to know basic code requirements. For example, the NEC includes restrictions on the proximity of electrical components and plumbing. Standards for electrical and communications systems are set by the following: American National Standards Institute, National Electrical Manufacturers Association, Underwriters Laboratories. The Americans with Disabilities Act specifies mounting heights for outlets and fixtures in handicapped accessible spaces.
It's good to know that we already have gained insights of different parts of electrical plan. I hope from this video, you will be guided in making, interpreting, analyzing electrical plan. To have a deeper understanding of our lesson for today, let us now begin on our discussion on basic technical drawing in electrical. I hope that you will learn a lot as we take our journey towards learning. Let us discuss the basic technical drawing in electrical. How do you think a basic technical drawing works? And what do you think it is purpose? Alright, let us find out. Basic technical drawing in electrical. An electrical drawing is a type of technical drawing that shows information about the power lighting and communications for an engineering or architectural project. Any electrical working drawings consist of lines, symbols, dimensions, and notations to accurately convey an engineering's design to the workers who install the electrical system on the job. A complete set of working drawings for the average electrical system in a large project usually consists of the following: a plot plan showing the building's location and outside electrical wiring, floor plans showing the location of electrical system of every floor, power riser diagram showing panel boards, control wiring diagrams, schedule and other combinations with construction drawing. Electrical drafters prepare wiring layout diagrams used by workers who erect, install, and repair electrical equipment and wiring in communication centers, power plants, electrical distribution systems, and building. Electrical drawings, sometimes referred to as wiring diagrams, are a type of technical drawing that provide visual presentations describing electrical system or circuits. They are used to explain the design to electricians or other workers who will use them to help to install or repair electrical system. But before we go to any further of the lesson, let us discuss the different technical lines used in drawing. Alphabet of lines. Each line in technical drawing has a definite meaning, and it's drawn in various ways. Visible lines. Visible lines are lines which are seen on the edge of an object. When drawn using the ink, the lines are heavy and solid. When pencil is used, the line produced is medium. The thickness of lines depends on the size of the drawing. Long break lines. Long break lines are lines which show that a line has been broken. These lines have definite breaks and are medium in weight. Short break lines. Short break lines are lines drawn with the heavy freehand line. Hidden lines. Hidden lines are also called dotted line. They are short medium weight dashes measuring about 3 to 4 mm wide. This kind of lines are used to represent hidden view of an object. A leader lines. A leader lines is a fine broken line. It has a narrow head at one end. The broken line has a short horizontal and inclined line to indicate either a part or measurement of an object. Reference line. Reference line is a curved line with an arrow at one end. This kind of line is used to label the parts of an object. Center lines. Center lines are lines used to pinpoint center of object, arcs and circle. They are drawn using one long and one short dash alternately. Section lines. Section lines are lines used to show sectional view. The spaces are placed evenly so that the shaded effect may be achieved. Dimension lines. Dimension lines show the measurement of an object. It consists of arrowhead, fine line, and the measurement. The arrowheads are short and placed at both ends of the line. The measurement is placed at the middle of the fine line. Now, let's come to the different types of drawing. Orthographic working drawing. Orthographic working drawing show the front, the top, and the right side views of an object. In orthographic drawing, lines are true size. Hidden lines are dotted center line, indicated circle, and cylinder. Isometric pictorial drawing shows three-dimensional views of an object. The height of the object is shown in vertical lines. The length and the width are the isometric axes that were drawn at 30-angle line, which is the true size. Isometric drawing usually has a center line and circle appears as ellipses. Hidden lines are not shown. Now, here's a video clip for you to be guided on how to make an orthographic and isometric drawing.
How to draw an orthographic projection. But first, what is an orthographic projection? Orthographic projection is the 2D representation of a 3D object. The 2D drawing represents the different sides of an object. Let's start!
Here, you will see an isometric drawing. What we want to do is to create the three views of orthographic projection. But first, let's make sure that we have the requirements: drawing table, pencils, eraser, 45-degree triangle, and the T-square that we will use for this test. First thing we're gonna do is we're gonna take a look on this object. This gonna be the front side. This is the right side. And this gonna be the top. Let's start. Draw the visible feature of the front view. Draw projectors off of the front view horizontally and vertically in order to create the boundaries for the top and the right side view. Draw the top view. Use the vertical projectors to fill in the visible features. Project from the top view back to the front view. Use the vertical projectors to fill in any missing feature in the front view. Draw a 45-degree projector off of the upper right corner of the box that encloses the front view. From the top view, draw projectors over 45-degree line and down in order to create the boundaries of the right side view. Draw the right side view. Then, label the three views. It's done!
Now, let us proceed to the parts of electrical plan and layout. Electrical plan is a technical presentation of electrical system proposed to be installed in building or house, which includes materials, devices, and equipment. Floor plan. Floor plan shows the layout of the location of light, switches, convenience outlet, and the power outlets. The following details can be seen in the floor plan. Number 1. Location, types and ratings of lighting fixtures. Number 2. Locations, type of power outlet and their ratings. Number 3. Outlet that belongs to that branch. Number 4. Location, type of control system used. Legend. Legend shows the meaning of each symbol used in electrical plan. The following are symbols commonly used in the plan. The load schedule. It helps determining the amount of power required for our installation. The following details can be seen in the schedule of load. Number 1. Number of branch circuit of electrical wiring system. Number 2. Number of lighting outlet, power outlet, and switches per branch. Number 3. Total wattage rating and of the load per circuit branch. Number 4. Total current load per circuit and the size of wire used. Number 5. Computation of total wattage and current of each circuit branch. Riser diagram. Riser diagram is a schematic presentation of the entire electrical circuit from the service entrance up to the smallest circuit branch. The following details can be seen in the riser diagram. Number 1. Character and types of service, single phase, 2-wire, or 3-wire. Number 2. Size of service entrance, conductor, and the conduit used. Number 3. Type and size of wire for each branch. Number 4. Size of protective for main circuit breaker and each branch. Title block. The title block or the nameplate indicates the following details. Number 1. Name and location of the proposed installation. Number 2. Name and address of the owner. Number 3. Name and signature and dry seal of master electrician or electrical engineer. Number 4. Printed name of the owner. Number 5. Initial of the draftsman and data when the drawing was done. Specification. Specifications includes the following. Number 1. Classification of service. Number 2. Types of wiring method to be used. Number 3. Number of branch circuit and their corresponding sizes. Number 4. Supplies, materials to be used by the contractor. Location map. Location map shows the following details. Number 1. Bordering areas showing the well-known streets. Number 2. Location of the utility company pole which supplies electric energy. I hope that what you have learned today will help you to acquire the skills that are required in your choosing specializations. May this learning be useful as well in your daily lives if ever you encounter situations that where these skills are needed. So that's it for our discussion on the basic technical drawing in electrical. Now, to check if you have learned something on this episode, let us have a quiz. Be ready with your paper and ball pen. Let's begin. What are the parts of electrical plan? Okay, class, let us check your answers. Are you ready? Alright. Number 1, floor plan. Number 2, legend. Number 3, load schedule. Number 4, riser diagram. Number 5, title block. Number 6, specification. And lastly, the location map. And that's all for today's episode of Technoskwela. I hope you have learned something from this lesson. If you have further questions about the subject, you may call, text, send message via messenger to your subject teacher or advisor. See you again on the next episode for new learning opportunities. This has been your teacher Jonathan for Technoscuela. We heal as one, we learn as one through Bayani Hands.
Ang ating radio and television-based instruction ay naisakatuparan dahil sa walang sawang pagsuporta ng ating City Mayor, Honorable Dexter Uy, ang ating Vice Mayor, Coefredo Tikwa Uy, at ng buong sangguniang panglungsod ng Catbalogan na pinangungunahan ni Councilor Honorable Step Uy-Tan. Kaya, ang DepEd Catbalogan City Division ay taos-pusong nagpapasalamat sa malaking suporta ng City LGU sa ating mga mag-aaral. Muli, maraming salamat sa inyong walang sawang pagsuporta.